Hello. Once again, I want to welcome you to the Computer Networking Basics for Beginners. This is a course meant for people who are new in the networking environment and people who are interested in learning the basics of computer networks. It's also a course for network administrators, network managers, people who are actually managing networks and things like that. This course is supposed to go from absolute beginner to advanced learner, okay? So it doesn't matter if you are just coming for the first time, this is the first place to begin, all right? If you have not watched the introductory video, please, you can go ahead and do so. Do well to subscribe and click the notification bell so that you can get notified of any new upcoming video. All right, having said that, today we'll be looking at Module 1 of this training. And Module 1 is going to be on the topic Communications in a Connected World. Communications in a Connected World. During the course, we are going to be focusing on the types of network and we'll explain the concept of what a network is all about. We'll be looking at data transmission and we will basically describe network data. Then we will also look at bandwidth and throughput. We'll explain the network transmission and speed and capacity. Those are what we're going to be looking at today. So let's go into it. Network types. Everything is online, which is true, especially in this day and day. The question we should ask is, how many of us still think that whether or not we are online? As it is now that I'm talking to you, you are over wherever you are, we are actually online. So we expect our phones, our tablets, our desktop computers to always be connected to the global internet. And someone may think that what is this global internet? It may think that a global internet is something that is located in the sky or something that is abstract. We will find out. We will use this network to interact with friends, to shop, to share pictures, experience, learn. That's all we use the network for. The internet has become such a part of our everyday life that we almost take it for granted. Typically, when people use the term internet, they are not referring to physical connections in the real world. That's what people are thinking. Instead, they think of it as a formless collection of connections. It is a place people go to find and share information. Now, this analogy or this concept is what is out there. This concept is what gives us the ideology of a network. But technically speaking, who owns the internet? Where is it? Where is it located? Is it located in US? Is it located in Nigeria? Is it located in the cloud? Is it located on the earth? Or is it located in another planet? Who manages it? Who is in charge of it? Can one person bring down the internet? Can one person decide to claim I'm the owner? Any individual or group does not own the internet, which is true. No one owns it. It is a worldwide collection. A worldwide collection of what? Networks. Operating to exchange information using common standard. The key word there is a worldwide collection of network, which means it is everywhere in the world. And different devices are connected to it one way or the other. You see somebody with a device here is connected to it. Another person is the device connected. So it is when all these individuals or devices actually connect to it directly or indirectly. The collection is what gives us the internet. In fact, the internet is two words brought in together. Inter and then net. When they say inter, we're talking about interconnection. When you're talking about interconnection, you're talking about when a set of devices actually connect to another group of devices. So interconnection of networks. And when you say a network, you are talking about a network is just the interconnection of two or more devices or end devices. So through telephone wires, fiber optic cables, wireless transmissions, and satellite linked internet users can exchange information in various forms, as we can see in this particular image. Everything that you access online is located somewhere on the global internet. Social media sites, multiplayer games, messaging centers that provide email and online courses. All these internet destinations connect to local networks that send and receive information about the internet. Think about all your daily interactions that require you to be online. When you pick your phone and you are using it online for your social media accounts, for banking services, to pay your utility bills, whatever you do, you are actually connected online. Now, let's look at types of network. One common type is called the local network. Local network comes actually in different sizes. They can range from simple network consisting of 2 computers to interconnecting hundreds of computers. So if I have a PC here, 1, I have another PC here, 2. They are independent computers. Maybe they are the laptop and a desktop or laptop and a laptop. And I decide to connect these devices either using wireless or cable. If I decide to just establish a connection between the two of them so that PC1 can be able to receive data from PC2, PC2 can be able to receive data from PC1, I have formed a network. So it is as simple as that. And it can be as complex as having hundreds of computers connected together within a particular area. So network installs in offices, homes, home offices are referred to as SOHO. SOHO means small office, home office. So part of this aim of this course is those of us who are new into this, by the end of the time, the course, we should be able to set up a small computer office or a small network in our homes. All right, something small. You should be able to do that. You should be able to set up a cyber cafe. You should be able to manage it or something like that. So SOHO networks let you to share resources such as printers, documents, pictures, music between the local computers. So maybe in a computer lab, you have 50 computers or maybe 20 computers and you have only one printer. How then can you be able to share all these computers to be able to print into this one computer? That is where you need a network because you need to share resources. Large networks can advertise and sell products, order supplies, and communicate with customers. Communication over network is usually more efficient and less expensive than traditional form of communication such as regular mails or long-distance phone calls. Network allows for rapid communication such as email and instant messaging and provide consolidation and access to information stored on the servers. Business and small office home networks usually provide a shared connection on the internet. So the internet is considered as what? Network of networks. Interconnection of networks. Networks of networks. You have networks of different organizations. Let's say banks. You have networks from GT Bank, network from Zenith Bank, network from Access Bank, network from First Bank. But if you pick your ATM card and then you go to any of these banks, you can withdraw money from any of them, which means that these banks are actually connected at a particular point. There is a point at which they get connected, and that's the point that we're trying to express, okay? So generally, we have what we call small home networks, and small home networks connect a few computers to each other and the internet. You have maybe 2 computers, 3 computers, 4 computers in your home, and then you are able to browse to the internet. That's like a small home network. Then you have the small office and home office network. All right. The small office, home office network allows computers in the home or remote office to communicate to a corporate network to access centralized shared resources. So if I work for an NGO and possibly the headquarters branch is in Europe and I live in Nigeria or US, I should be able to access the resources in that corporate office right from my home or right from a small office here. And then I'll be able to carry out my duties or my services. That is the concept here. So these days, what organizations do is you host services in the cloud and then you are able to access it everywhere. Then we have what they call the medium to large network. The medium to large network, such as those used by corporations and schools, can have many locations with hundreds or thousands of interconnected hosts. Okay, then you have what we call the worldwide network. The internet is a network that connects hundreds of millions of computers worldwide. Now, let's look at mobile devices. When we say mobile devices, they are just devices that you can hold in your hands and move around with. They are mobile. So the internet connects more computing devices than just desktops and laptops. There are several devices all around you may just interact with daily that connect to the internet. You know, varieties, laptops, mobile phones, tablets, palm tops, and things like that. And smartphones connects to the internet from almost anywhere. It combines the function of many different products such as telephone, cameras, GPS, receivers, media players, touchscreen computers, and so on and so forth. Example of my smartphone, okay? Then you have your tablet. It also have the functionality similar to that of smartphone with the additional screen size. So what differentiates it is the size of the screen. They are ideal for watching videos and reading magazines or books. You know, with a wide screen keyboard uses many things to help you work, like you're using a computer. You also have things like smartwatch. They are mobile devices. It can connect to your smartphone and provide the user with alert messages. Additional functions such as heart rate monitoring and counting steps, like speedometer, can help people who are wearing those devices to track their health. Then you also have the smart glasses, okay? The wearable computers in the form of glasses such as Google Glass contains a tiny screen that displays information to the wearer, similar to the fighter pilot's heads-up display, okay? Those are mobile devices. Let's look at connected home devices. Many things in your home can connect to the internet to be monitored and configured remotely. One is your security system. Many home items such as security systems, lighting, climate controls can be monitored and configured remotely using mobile devices. That is where the idea of what we call smart home comes into play, or where the idea of what they call Internet of Things, IoT, comes into play, where everything on your house or everything around is connected to the network, okay? Appliances like household appliances such as refrigerators, ovens, dishwashers can also connect to the internet. Surprise? Yeah, surprise. They can connect to the internet, allowing the homeowner to power on or off, monitor the appliance status, and be alerted to preset conditions, such as when the temperature in the refrigerator rises above the acceptable level. So if your fridge is misbehaving, you get an alert. Another one that is very common to us is the smart TV. It can be connected to the internet across, the content without needing TV service provider equipment. All right. Once you connect to the internet, either wirelessly or using cables, you can even watch Netflix, you can watch some YouTube, you can watch a lot of device applications. All right. You can even browse the internet on those TVs. You can even send emails if you so wish. You can play audio and things like that. Another interesting device in the home that is connected to the network is the gaming console. Gaming consoles connect to the internet to download games and play with friends online. So now you see these devices are particularly in the home. In the home. So within your home, you can have a small network and connect all these devices to your network, and you carry out whatever it is that you do. So we have seen mobile devices. We have seen devices we connect from our home. Let's look at some other general devices that can be connected to the network. Some of them include the smart cars. All right, we're in the modern age. So many modern cars can connect to the internet across the map. Audio and video content, or even information about the destination. All right, you've heard about Tesla. Is that not so? It's one of the latest smart cars. They can even send messages or even email, right? If there is an attempt of theft or call assistance in case of accident, the cars can even communicate with your emergency number, or it can call the state emergency response number. These cars can also connect to your smartphones, to your tablet, and even display information about the different engine systems that provides. So if there is a section of your engine that requires maintenance, you see it on your phone. Okay, if your fuel is going low, it tells you that, okay, this fuel is going to serve you to so location, this kilometers or this mileage, right? So that is it. So smart cars are these days connected to the network, and enormously they are doing fantastic. Another one is called RFID tags. RFID simply means radio frequency identification tags. Okay, so they are placed in an object in order to track or monitor the object. You find them maybe in libraries. Some libraries put RFID tags on their books so that if anybody is going out of the library with that tags is noted. Some organizations put that chip in their staff identity card so that as the staff comes to office, as they swipe the device, it's documented. When they are leaving, everybody knows. So these tags can be can be inserted in any device. Anything that you would want to monitor, you would want to check, you want to keep track, fine, the RFID tags takes place. And then you have the sensors and actuators. The connected sensors provide temperature, humidity, wind speed, barometric pressures, and soil moisture data. Actuators can then be automatically triggered based on the current condition. For example, a smart sensor can periodically send soil moisture data to a moisturizing station. The monitoring station can then signal the actuator to begin watering. The sensor will continue to send soil moisture data, allowing the monitoring station to determine whether to deactivate the actuator or not. So this is in the area of farming. Okay, the area of farming, but not just farming, any other sector that you want to use it for remote monitoring, or to say, okay, I want you to monitor this condition. Once it meets this, then act in this way. You could decide to set up a room heater in your house and then an air condition. And you set up the process to say, if the temperature in the room goes below, probably, let's say, below 15 degrees or 13 degrees, that means the room is extremely cold. Then the air condition should stop, and then the room heater should on automatically. Or you could say, if the room temperature goes above maybe 18 degrees or 19, you say, you want the air condition, the room heater to stop, and then the air condition to start in. So these are examples of how you can make use of it. Then you have medical devices, such as pacemakers, insulin pumps, and hospital monitors. You know, these days, even these heart rate monitoring devices that they put on your wristwrap. You know, the technology in advanced countries says that You wear it, and probably you are moving if you have a heart condition or you have a heart problem. If you are wearing it and you are moving across, probably something happens and your heart begins to pump and you are having a heart attack. A signal sends from the device to the hospital. And then the hospital sees that, oh, somebody is about to have a heart attack. The hospital now sends an alert to the doctor. And then, if your patient is about to have a heart attack, immediately the hospital now sends the ambulance, and the ambulance gets the signal with your own geolocation. So you may be walking along the street, and then suddenly you see an ambulance. Please, mister, can you enter? You are about to have a heart attack. So you see, before you even have the heart attack, you are in the ambulance and they are rushing into the hospital. That is, the power of mobile devices. Now, let's look at the next section, which is data transmission. Now, when we say data transmission, we are talking about when data moves from one device to the other. All right. And for us to understand, we need to understand the smallest unit and value of data before we go to understand how it moves from one point to the other. So the smallest unit of data is called bits. When you say bit is two words that are combined together. And those two words are what they call binary digits. So do you know that computers and networks only work with binary digits, zeros and ones? It can easily be imagined that all our data is stored and transmitted in bits, whether numbers, alphabets, pictures, sound, videos, all of it. Each bit can only have one or two possible values, 0 or 1. The term bit is an abbreviation of binary digit, and represents the smallest piece of data. So how did they come across this binary digit? If you say binary, it picks the B of binary and picks the last two letters of digit. That's how it formed bits. So humans interpret words and pictures computers to analyze only patterns of bits. A bit is stored and transmitted as one of two possible discrete states. This can include two directions of magnetization, two different voltages or current levels. So the concept of using binary is because it gives us a two-state circuit. It is either on or off. It's either there is or there is not. Okay, so it makes it very easy. So now, every input device, whether it is a mouse, a keyboard, a voice-activated receiver, whatever input device, scanner, will translate human interaction into binary code for the CPU to process and store. All right. Remember, in the concept of computer processing, you have to collect the data as input, then you process the information, then you give it out, you store it, then you give it out as output. Okay. So when you collect the information, that is where this comes in. So every output device, printers, speakers, monitors, etc., will take binary data and translate it into human recognizable form. So you see, these are two extremes. So I pick an input device, it picks from human understandable form and convert to machine understandable form. Then the output device will pick from machine understandable form and convert back to human understandable form. So within the computer itself, all data is processed and stored in binary. Computers use binary codes to represent and interpret letters, numbers, and special characters, with bits. So a commonly used code is what we call the ASCII code, right? This word ASCII is an acronym. It's an acronym that stands for American Standard Code for Information Interchange. What does it mean? It's just a system where some set of numbers are set to represent binary digits. Not just numbers, all set of characters. Very good, that's the word. Some set of characters, about 128 characters, are set to represent binary digits. All right. So for example, when you say capital letter A. Capital letter A is represented as this. How is it represented as this? We will talk about it very soon, where you will now see the concept of the ASCII code. Number 9 is represented as this. So all the possible characters that you can have on your keyboard, from A, capital A to Z, from small letter A to Z, from your numbers 0 to 9, from your special key or characters like zero, like comma, at, punctuation marks, all of those, they are represented in the ASCII table. So each one of them that is in the ASCII table has a corresponding binary value. All right? So that binary value is what the computer uses to understand. So each group of 8 bits, such as the representation of letters and numbers, is known as a byte. So now we have seen bits. Bit is a single binary digit. Is that not so? A byte is a combination of 8 bits. 8 bits make 1 byte. So how do you get a byte? Like a character. Each character gives you a byte because each character will make up to 8 bits. So for instance, this capital letter A here, if you look at this capital letter A, it has to be represented in binary and it has to be up to 8 bits. Right? So that is it. So each group of 8 bits is represented as bytes. So the use of codes can represent almost any type of information digitally, including computer data, graphics, photos, voice, videos, and music. All right. So now that we've understood the concept of the data, let us look at the common methods of transmission. Right? So after the data transforms into bits, because you would have collected it from input, okay? Then you will now convert it into bits. It converts into signal sent across the network media to its destination. Media refers to the physical medium on which the signals are transmitted. Examples of media includes the copper wire, includes the fiber optic cable, and include the electromagnetic waves. So these are the basic 3 network media that we have. So when you say the copper wire, there are different types of cables that relates to the copper wire. Number 1, there's what we call the UTP cables or the STP cables. All right, those type of cables, you use them to convey data, in local area networks. Okay, we'll talk about those very in subsequent topics. Then you have another type of copper. There is this one you use to connect your external dish, maybe your DSTV or your cable satellite or whatever it is. All right, we call them coaxial cables. They have copper inside and things like that. So why they are using copper? Because they carry data in form of electrical pulses. So in form of electricity, that's how they carry data. The next one is fiber optic. Fiber optic actually uses pulses of light in order to carry data. So it conveys information using pulses of light as it moves the data across. Then the next one is the electromagnetic waves, which is the wireless. All right, the Wi-Fi that the wireless signal and things like that. So it conveys it using electromagnetic waves into the air. So those are the method or the medium where data is then transmitted. Remember, before it's transmitted into this medium, it must be converted into a machine understandable form. That is the bits where we are talking about. So these patterns represent the bits or the data, and they travel across the media from source to destination. So signals may be converted many times before reaching the destination as the corresponding media changes from source to destination. So if I'm using copper cable, and then at a point in time I'm using fiber optic, at the point in time I'm using wireless, so the conversion, the data will be converted in those points. All right. Common methods that you can see: pulses of electricity, this is where copper comes in. Pulses of light, this is where fiber optics comes in. Radio waves, this is where wireless comes in. So we said that electrical signals transmission is achieved by representing data in electrical pulses on the copper wire. So the data, which is in form of zeros and one, is now converted into the way electricity behaves. Okay. Then for the optical signal, transmission is achieved by converting the electrical signals into light pulses. Then wireless signal transmission is achieved by using infrared microwaves or microwaves through the air. So most homes and small businesses transmit network signals across these wires or using wireless. Then finally, let's look at the concept of bandwidth and throughput. Now, the concept of bandwidth and throughput is related to the network medium. Remember, we said we have three major network medium. We have the copper medium, we have the optical medium, which is the fiber optic, and then we have the electromagnetic medium, which is the wireless. Now, each of these medium has the capacity of carrying data to its maximum. Okay, so we are going to be seeing the maximum capacity that can be conveyed data through a particular medium is the bandwidth. So if, for instance, this is a pipe, okay, if, for instance, this is a pipe, or let's say this is a pipe, for instance, this particular pipe can be able to carry the amount of data based on the size of that particular. That's the bandwidth. The throughput, on the other side, is the actual amount of data that is passing through that channel. The throughput cannot be more than the bandwidth. Okay? So streaming a movie or playing a multimedia games require reliable, fast connection. Network can transmit and receive bits at a very high rate to support high bandwidth applications. Different physical media supports the transfer of bits at different speeds. So the data transfer rate is usually discussed in terms of bandwidth and throughput. So bandwidth is the capacity of the medium to carry data. The digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. So bandwidth measures the number of bits that are theoretically sent across the media in seconds. Okay, so the bandwidth may vary based on the size or capacity of the network medium. All right, so for instance, we need to understand the measurements of bandwidth. Then we will now go to the medium and see how they are actually measured. So the measurements include kbps. Kbps means thousands of bits per second. When you say kbps, means kilobits per second. Then you have mbps. mbps means millions of bits per second. All right, megabits per second. Then you have gbps, which is talking about billions of bits per second. All right, or we call it gigabits per second. So that's how your bandwidth is measured. Now, the physical media properties, current technologies, and the laws of physics all play a role in determining the available bandwidth. The table shows the commonly used measurement of the bandwidth. So when we say bits per second, that is this, which is the fundamental unit of measurement. Kilobits per second, we're talking about thousands. Okay, megabits per second, we're talking about millions. Gigabit per second, we're talking about billions. Terabits per second, we're talking about trillions. Okay. Now that we've understood the bandwidth, now let me say this. If you have a pipe like this, you have a pipe like this, then you have another pipe like this. This is pipe A, this is pipe B. And yeah, now the size of this pipe, let's say this is 1 meter. This one maybe 2 meter. Now, if you have these pipes, the amount of data that can pass through here cannot be more than the size of the device. The amount of data that can pass through here could be twice the size of the first pipe. So the bandwidth in A is lower than the bandwidth in B because of the capacity. But now, the throughput on the other side, it says like bandwidth, throughput is the measure of the transfer of bits across a given period, which means if this pipe here, this is a 2 meter pipe. If you decide to pass traffic here in maximum capacity, let's say you will get 1 gig. In maximum capacity, you get 1 gig. But if you are not passing the traffic in maximum capacity, maybe you are passing the traffic in something, that is actually the throughput, because the throughput will tell you the actual amount of data that is passing through that channel. However, the throughput does not usually match the specified bandwidth due to several factors. Many factors include the amount of data being sent and received over the connection. Sometimes the types of data being transmitted matters. Another time, the latency created by the number of network devices encountered between source and destination also matters. What we mean is that, for instance, I start, this is a 2 meter capacity, and then I now change to a 1 meter capacity. 1 meter capacity. That means the data that is here can move capacity of 2 meters, but when it gets here, it will be congested to flow through 1 meter capacity. So the throughput, the bandwidth now is reduced, but the throughput now is the actual amount of data that is there. So throughput measurement do not consider the validity or usefulness of the bits being transmitted and received. Many messages received through the network are not destined for specific user applications. An example could be network control messages that regulate traffic and correct errors. And, in an internetwork or network with multiple segments, throughput cannot be faster than the lowest link of the path from the sending device to the receiving device. So even if all or most of the segments have high bandwidth, it will only take one part in the path to lower the bandwidth to create a slowdown of the throughput of the entire network. So many online speed tests can reveal several throughput of an internet connection. In summary, what did we learn in this module? We learned that the internet is a worldwide collection of interconnected networks cooperating to exchange information using standards. We also learned that internet users can exchange information in various forms through telephones, wires, fiber optic cables, wireless transmissions, and even satellite links. Small home networks connect a few computers to each other and the internet. The small home office network allow computers in the home or remote office to connect to the corporate network or access centralized shared resources. Medium to large networks, such as those used by corporations and schools, can have many locations with hundreds of thousands of interconnected hosts. And we saw that there are devices all around that may interact with daily and connect to the internet. Okay. We also saw that things in your home can connect to the internet, such as your security system, appliances, smart TV, and gaming consoles. Outside your home, there are smart cars, RFID tags, sensors, actuators, and even medical devices that can be connected. So the categories used to classify types of personal data our volunteer data, observed data, and infrared data. These and many more is what we have learned. If you like this video or you have found it very informative, please click share and like. Also subscribe so that you can also get notification. I want to say here also that if you have a question as regards what we have taught, you can also drop your question in the comment section. We'll be able to respond to you there. Once again, thank you very much for your time. Thank you for this session. We look forward to meet again in Module 2. Thank you.